All right, today we're looking at compare and order rational numbers, okay? Um, so first thing is, what is a rational number? Let's get a definition. All right, rational numbers are numbers that can be written as fractions. All right, any number that can be written as a fraction is a rational number. So examples are fractions, like 1/2. Obviously, a fraction can be written as a fraction. Whole numbers, positive and negative, like -6 could be like -6/1. That's a fraction. That could be written as a fraction. Terminating decimals, like 0.45. Those can be written as fractions, right? We just did that, right? 45/100. Okay. So yeah, we can say that's 45/100, right? And then also repeating decimals, so like 0.3 repeating, which is 1/3, right? That can be written as a fraction. So that's why we focused on those yesterday's lesson is repeating decimals and terminating decimals are rational numbers. That's why we're kind of like separated them from the rest of them. Okay. So again, another example would be like pi. Pi is not rational. Um, I like to think it as if you're irrational, right? That's another word for saying you're kind of crazy. Okay. If you're kind of crazy, then you go on forever and you ramble and ramble, ramble, and that's what some of those will do, right? Okay. Um, whole numbers can be fractions again, because like for example, -6 could be, I'll put that -6/1, right? That's an example of it could be written as a fraction. So when we talk about rational numbers, that's what we're talking about. Right? Okay, let's talk about comparing fractions. And when I say comparing, what I mean is we're going to use greater than, less than, and equal to. Okay, that's what we talk about with comparing. Greater than, less than, equal to. So let's start with an example that you guys have probably seen before. We're going to jump straight to kind of ones that are a little bit more difficult. Let's take, for example, 5/6 compared to 7/9. All right, now here's the thing. We know that we can't just say, well, 7 is greater than 5, and that's why, right? Think of it this way. When you're comparing fractions or comparing anything, you have to be on the same playing field. For example, let's say that you and your friend were going to race. Okay, let's say who's the fastest. And so the best way to tell who's the fastest is you race. Now, let's say that you run 100 feet and the other person runs only 10 feet. And they said, well, I finished faster than you. Well, that's not a fair race, right? You can't compare those two things, right? It's not like, hey, I had to run 100 feet. You only had to run 10. Of course, you're going to finish faster than me. That does not mean that you're faster than me, right? Instead, you have to say, well, if I run 100, then you have to run 100. You have to run the same amount of distance. Otherwise, it's not fair. Same thing with fractions, okay? Instead of a race and racing the same amount, you need to have the same denominator, okay? Same denominator in order for you to compare the two. So right now, the denominator is different, right? We have 6 and we have 9. That's not going to work out. So we're going to have to change both of our fractions to have a common denominator. So I'm going to go over this again. You guys have probably seen this before about changing denominators, but we'll go over it really quickly. How do I change denominators? Well, I need to find the LCD, the least common denominator. So how am I going to do that? Let's start with writing out all the multiples of the denominators. So I've got 6, 12, 18, 24, so on and so forth. From 9, I've got 9, 18, 27, 36. Okay. I keep going until I find something that matches. Right? So step 1 is to find a common denominator. Okay. In this case, I see that 18 works for both. Right? That is the least common denominator, the smallest one. Now, there are lots of numbers. There's an infinite amount of numbers that are in common with 6 and 9, but we want to know the smallest one. We like smaller numbers that are easier to work with. Okay, step 2. Change your fractions so that they have the same denominator. How do I do that? Well, let's go ahead and do this together here. So let's start with 5/6. So I know to get to 18, I need to multiply by 1, 2, 3. So I'm going to multiply the top and bottom by 3. 5/6 times 3/3. I'm going to write this actually down instead of right next to it. You'll see why in a second. So that makes 18 on the bottom and 15 on the top. Okay, for 9/18, I'm going to change 7/9. I need to multiply by 2. I get 18 on the bottom and 14 on the top. So which one is greater? Right? Which one is greater? Well, 15 is greater than 14, so I can put it there. Or if I go back to the original problem, it should look like that. Right? Remember, the mouth always opens to eat the greater side. Okay? You guys see that? Yeah, for comparing fractions, this is all you got to do. And sometimes they're actually easier than that, right? So let's go back to what we did here. First, we changed our fraction, or we found the common denominator. We changed our fractions, and then we're ready to compare. So let's have you guys do a few examples here. How about if I had 1/5 compared to 7/50? Go ahead and try that one on your own. All right. Good job. Yeah, some of you guys are putting in the chat. Good job. Okay. Now, what's cool about this one is I don't have to change both fractions. Right? Because what's the common denominator here? What numbers did both 5 and 50 go into? That's the question. Right? We got to think about both 5 and 50 for our common denominators. Well, what's easy is 50, right? 50 is my LCD. And if 50 is my LCD, then I don't have to change anything. So here we go. So this should be, I just need to change this one times 10, right? So 10/50. I multiply the top by 10 and the bottom by 10 compared to 7/50. Now we're dealing with the same playing field, right? There you go, good. And so now you can say, okay, it should go this way. If you want another example, it's kind of like if you said, hey, I ate 10 slices of pizza, but they're all really small slices. That's different than ordering, like, say, I ate 10 regular slices, right? We got to make sure our slices are the same. We got to make sure that's the same. In this case, 50. So just like that, right? 10 is greater than 7. All right, here's another one. I want you guys to try and do this one. How about, what if we have negatives? Negative 4/7 compared to negative 5/8. Ooh, tricky. All right, see if you can figure this one out. All right. This one's a little bit tricky. Okay, so here we go. First of all, you might have thought, okay, 56, right? 56 is my common denominator, right? My LCD is 56, so I just have to multiply 7. There's nothing that goes in 7 and 8 except for each other. Okay, so I got to multiply this one by 7, and I got to multiply this one by 8, all right? 4 times 8 is 32. 5 times 7 is 35. But remember, they are negatives. Okay, so the question is this. You look at them and you say, okay, well, 35 is greater than 36, right, Mr. Leong? It should go like this. Ah, you have to be careful. Remember, when we're talking about negative numbers, we want smaller negative, right? Oh, yeah, huh? It should actually go like this. Negative 32 is greater than negative 35. Ah, so we got to watch out, okay? Watch out for your negatives. Right? Watch out for those negative numbers. They're always kind of tricky. Okay, so that's a big part of the homework today. Okay, another part trying to squeeze in is what if you have to compare? Okay, percentages and fractions. What do you have to compare percentages and fractions? So, for example, let's say that 37.5% of the students that we asked said they like bowling the best. And 12 out of 29 said they like basketball the best. So, which is greater, bowling or basketball? What do people like better? Now, you might think, well, it's easy, Mr. Lang. Basketball is better than bowling. Some of you are like, no way, bowling is better. Okay, so here's the deal. 37.5 is in percentage form. 12.929 is in fraction form. So again, we got to get them on the same playing field, right? Just like our whole 100-yard thing, right? 100 feet running a race. We either can change a fraction to percentage or percentage to fraction, or actually, this is what we're going to do. We're going to change both to decimal. That's the strategy. Change to decimal form. Why would I do that? Why would I change them to decimal form? Because watch. 37.5%, that's easy as a decimal. That's 0.375. Right, remember that? Just move the decimal 2 places. Okay. Now, can I change this fraction to a decimal? Yeah, that's what we just did, right? In yesterday's lesson, we changed that to a decimal. So let's go ahead and do that. Unfortunately, only way is long division. But here's the cool thing. All right. Here's what's cool about this. Okay. We don't Okay. We don't need to do division all the way. What do I mean by that? Check it out. 29 goes into 120. 29 is almost 30. 30 goes into 124 times. And I'm done. I know that's, look, isn't 0.4 greater than 0.375? Right? No matter what's after this. I didn't even finish the problem. That's okay. 0.4 something is greater than 0.3 something every time. Yes? So you don't have to divide the whole thing. All you have to do is find out where it's greater. In this case, 0.4 is greater than 0.375. So the answer is basketball. More people like basketball. So changing things to decimal is going to help us out a lot. I know I did this one kind of quickly, but basically change two things to decimal and then figure out their order or figure out which is better, right? Last thing here, we'll kind of squeeze it in. This will give us a more clear example of this, okay? Let's say we were going to compare four numbers from least to greatest. (23%), 0.21, 1/4, and 1/5. So I'll give you a second to write these down. I know I'm going pretty fast here. Let's say I want to compare these, and I want to go from least to greatest. I've got fractions, I've got decimals, I've got percentage. Well, this is what we're going to do. The easiest way to do it is change everything to decimal. Decimal is the one that's easiest. Really? Yeah, let me show you. Watch. 23% as a decimal is simply 0.23. 0.21 as a decimal is 0.21. Do you guys know what 1/4 is as a decimal? You should know that one. If you have 1/4, you've got a quarter, so that's 0.25. And if you don't know 1/5, that's one you should memorize. 1/5 is the same as 0.20 if you do the division. You guys can trust me on that one. Okay, so what's the least? Now put them in order. Look, 20, 23, 25, 24, 21. Put them in order from least to greatest, but write them in the original form. So the least is 0.20, so that's 1/5. Next, 0.21, so 0.21. Next, 0.23, so 23%. And lastly, the greatest one, 0.25, 1/4. Okay? So changing things to decimal, which we did yesterday, it will help you a lot in putting things in order.